for the invitation. Thank you for the organizer that organized this wonderful conference and invite a wonderful economist. I will try to take my chance and not to take my time. So, okay, well, this paper is, I'm coming to this research from decision theory, namely from another tradition than the tradition that exists in intertemporal choice. In intertemporal choice is dominated by a tradition of optimization, as was demonstrated by Nicolas, even if he adds to optimization considerations, axiomatic considerations. And when it comes to eliciting or measuring preferences over time and under uncertainty, I think there are a lot of complications that come from the fact that we don't have simple axiomatic setups in which one could deeply understand how to measure preferences over time and under uncertainty. So this paper has started with a personal frustration that I share with my co-authors. And this frustration came from the fact that in 2012, I think, there were two empirical papers published by Abdellaoui and Springer in the American Economic Review in the same issue that were using discounted expected utility to measure both utility and discounting. The first paper have insisted or have focused on the fact that one could not elicit correctly preferences if one have to consider only one single utility function. Let me remind you one thing about discounted expected utility and then try to explain what is the contribution of this paper. So the discounted expected utility as a model is, well, this is the workhorse of economics, by the way. It is used everywhere to model individual behavior. And it's a matter of fact. It's just a combination between Samuelson's discounted expected utility and von Neumann-Morgenstern expected utility. But one thing that appears here, if you look carefully at these two formulas that are very simple, is that you have Samuelson have considered a cardinal utility, which is the V here, and for Neumann-Morgenstern have considered also a cardinal utility, which is U, which is a utility that exists under risk. And there was this discussion in the 50s of the last century between Maurice Allais and Savage and other economists like Samuelson about the very nature of this guy, namely the very nature of the utility function. And people have converged, and the average economists have converged to consider that this is a specific index to risk. So this has nothing to do with the old cardinal utility, the old-fashioned cardinal utility used in economic analysis. But at the same time, people did not focus on this guy. And this guy is a cardinal utility function. And there is no risk entailed in it. So when these two models were combined as discounted expected utility, so there was a choice that had to be made, namely one had to take into account one single utility function, and this was done. They take into account the main promoters of this model take into account that V is identical to U, which is to some extent in contradiction with all the debates about the very nature of the utility function. But this genetic problem in this model has generated tons of empirical problems later. And hence this publication by Abdellaoui and Springer, in which they easily show that when you elicit a utility function under risk, and you elicit a utility function under over time, you find that these two entities are not identical. What to do? And then we got stuck with this problem. So some economists later, like for example, there were a few comments on the paper by Abdellaoui and Springer, and in particular there was a comment by Miao and Zhong, in the American Economic Review 2015, in which the authors have used a model which has nothing to do with what Andreoni and Sprunger did, but which share the fact that it is a discounted expected utility after all. They used the Krebs and Porteus model. And in Krebs and Porteus model, well, this was a generalization of discounted expected utility, which was a recursive generalization of expected utility in which Krebs and Porteus try to take into account delayed resolution of uncertainty by introducing a second utility function. But this model, like Krebs and Porteus, also benefit from this genetic problem, namely that they could not distinguish between the V, which is a cardinal utility under certainty, and U, which is a cardinal utility under risk. So a lot of people have used Krebs and Porteus just to distinguish between intertemporal substitution and attitude toward the risk, which is not correct. Formally, it's not correct, because the Krebs and Porteus model was devoted to take into account delayed resolution of uncertainty. But this contradiction comes from this fundamental problem. So we are here about treating this fundamental problem on a theoretical ground as well as on an empirical ground. I will try to convince you that the lack of an axiomatic setup in which we could develop discounted expected utility or some generalization of it have contributed to this confusion in the existing literature. So the outline of the talk, I will start with few introductory remarks, then generalization of, I will try to provide you with a generalization, with a simple generalization of discounted expected utility. I will, in the setup I will propose, we can easily get discounted expected utility, generalized discounted expected utility, and rank-dependent discounted utility. Then I will try to illustrate how, for example, risk can impact discounting. And finally, I will try to give you an idea about an experiment we realized a few months ago. Okay, so let me start here. If you take into account the combination between discounted utility and expected utility within discounted expected utility, you can see easily that discounted expected utility has a constant discounting from the early beginning. So we have the problem of non-constant discounting, and we have a depressing list of empirical findings showing that we have problems with constant discounting. I'm talking from a descriptive point of view, not from a normative point of view. So we have also deviations from expected utility, and we have also even longer depressing list of findings showing that we have tons of departures from expected utility. And finally, we have this new empirical investigations showing that we have non-interchangeability between utility indexes when it comes to Samuelson discounted utility or for Newman-Morgenstern expected utility. So empirically, this questions the reliability of empirical measurement assuming discounted expected utility. If you assume discounted expected utility, then you have to endure these discrepancies. Either discrepancies from constant discounting, deviations from expected utility, or the non-interchangeable nature of V and U as utility indexes. Okay, so what the present paper is about. So the paper proposed and illustrated two generalizations of discounted expected utility. And the paper is indeed consists in two contributions. The first is theoretical with one PhD student at HEC and Horst Song from University of Manchester. So here we have the first generalization of discounted expected utility we propose is called generalized discounted expected utility. And what it adds to discounted utility, it adds the possibility to have different utilities between risk and time. The second generalization is a little bit more sophisticated in the sense that in addition to the fact that it takes into account two utility functions, it also takes into account the possibility to depart from expected utility and exhibit probability weighting. Here are a few graphic illustrations. For example, here for the utility index, if you have, this is the axis of outcome, this is utility. So if you consider two utility functions, then you have to take into account the utility over time, and this is the utility and the risk. In fact, this reflects the findings, the empirical findings we have. We have a more concavity for the utility for risk than the utility for time. And this was systematic, and we have at least 3 recent papers showing that clearly. Well, this is just an illustration of differences between exponential discounting and, for example, the constant discounting, the constant sensitivity discounting function proposed initially by Drazen-Prelec. And finally, you have this discrepancy, this popular discrepancy popularized by prospect theory, namely that people, instead of exhibiting linearity in the probabilities, people exhibit overweighting of small probabilities and underweighting of moderate and high probabilities. And this is the common finding that have to be taken into account. So the idea here is to say that if you assume discounted expected utility, then you will miss these things. You will miss discrepancies from expected utility and discrepancies from discounted utility, and then you will end up with elicitations that are distorted. Yes?
There is not a third curvature, which is the marginal utility of money. So there is no time, there is no risk, but if you give me more money, my utility...
Yes, absolutely, yes.
That's another one? Or...
No, absolutely. Well, let me go back to what you have here. Well, this is just an illustration. It is not backed by data. I will give you more information about it. Okay, let me come back to this. Because when it comes to eliciting, for example, the utility and the risk, you have 2 ways to elicit. Either you assume expected utility, and in such a case, you integrate in its curvature the probability weighting function curvature, or assume a more general model, like, for example, rank-dependent utility prospect theory, in which case you get, let's say, a weaker curvature as compared to what you obtain under expected utility. So under expected utility, this is almost a fake. You obtain an exaggerated curvature. Why? Because you could not take into account probability weighting. Probability weighting is taken into account within the utility function. Okay, so well, let me now present the formal setup. In the formal setup, let me start with few notations and definitions. Okay, so our object of choice here are contingent consumption plans, and I will use this notation, namely x tilde represent just a probability distribution over streams of outcomes, consumption streams. So this is a contingent consumption plan. So this gives you x1 with p1, the stream x1 with p1, stream x2 with p2, and so on. So this is just a presentation, well, like in what we did in what we are doing in decision theory. This notation also will facilitate a little bit our job when it comes to the presentation of the main conditions, namely that alpha tx, x is just a stream of outcomes, deterministic stream of outcomes, is just the stream where xt, consumption xt, is replaced by alpha. So this is just a notation that would facilitate a little bit things. Well, now the contingent consumption plan, and this is also a notation, the consumption, if you take a contingent consumption plan and you replace x2 by y, we adopt this notation, and this p2 indicates the probability that gives birth to y. So this is y p2 x tilde is correspond to this consumption, contingent consumption plan. Okay, now combining these notations, for example, here the contingent consumption plan alpha tx p2 x tilde is just the consumption plan in which the second stream x2 was replaced by alpha t x2, and that's it. Okay, so this is now the discounted expected utility value of this guy, namely of this consumption plan. Discounted expected utility gives you just an expectation, it's just an expected value of discounted utilities. So this is the discounted utility. This is a way to write discounted expected utility. But now the first new functional we propose in this paper is this one. Namely, if you have a contingent consumption plan you can take into account now, you can introduce, instead of ignoring an alpha here, we introduce an alpha that transforms discounted utility. So in this case, for example, you could imagine a situation in which you replace all streams here by present values, for example, and then you will end up by a simple probability distribution, and then you could replace this guy by just the value of this present values. So in such a case, as we will see later, you will see that the composition between phi and v represents the utility for risk. So this is, the phi here is introduced as something, as some additional flexibility that allows to distinguish between v as a value function and the utility function a la von Neumann-Morgenstern. Then we introduce a third way of evaluating contingent consumption plans, and the third way is called a rank-dependent discounted utility, and it consists in replacing probabilities by decision weights as under rank-dependent utility, and assuming that we have two utility functions, namely one utility function for time and one utility function for risk that consists in the composition between phi and v. So here we take into account two utility functions and probability weighting, and in addition to this, we take into account also a non-necessarily constant discounting. This is the general discounting function, so from the early beginning. So here, as you can see, the composition between phi and v stands for the utility for a risk. And this formula gives you the decision weights. Anyway, this is not that important at this stage. You can observe also that I take into account here, the rank ordering of consequences as usual under rank-dependent utility, when I have to take this into account from the early beginning. Okay, here are the standard axioms. Well, the standard axioms we take into account are really consistent with standard economic theory. Namely, we start with a preference relation which is complete and transitive over the set of all contingent consumption plans. Then we also take into account monotonicity, and monotonicity, the standard monotonicity condition. Namely, if you take this contingent plan and you improve it at time t, then you will prefer it to the other. If you take this contingent plan and you improve it at t by replacing beta by alpha, then you will get something that you prefer. So this is a mild monotonicity condition, strict monotonicity. Then we take here also a continuity condition, which is just Euclidean continuity, nothing new. So all these conditions are standard conditions, and I have here a little bit tricky condition that means that you have, or the preference relation satisfies what I call conditional constant equivalent independence, and this warrants that each contingent consumption plan can be replaced by a unique analog where streams are replaced by constant stream. Let me just explain this. If you take, for example, this contingent consumption stream, then you could replace by continuity of the weak order and the monotonicity, you can replace this guy by something constant, by just a constant stream, and constant stream, and constant stream. And this allows you indeed to disentangle attitude toward risk from attitude toward time, because you end up with something which is a probability distribution over scalars, over scalar consumptions that could be identified with a constant. Okay, so if you account for these axioms, then when you need the key axiom, and the key axiom is here. The key axiom, at least for discounted explicit utility, so we say here that the preference relation satisfies what I call substitution consistency, and this is an extension of a few consistency conditions that were proposed initially by Peter Wacker and Veronika Köberling more than 15 years ago. So it is apparently complex, but it has nothing complex in it. If you focus on these two indifferences, for example, you can see that I have just here, I have contingent consumption plans, and I have here alpha, beta, and gamma delta, and they have the same timing here, t, and the same timing here, t, and the same probability here, and the same probability here. So the modification here is conditional on pi, and the modification here is conditional on pi, and so on. So if you take this into account, and you look at, and you think in terms of discounted executility, then you can easily determine the value of this guy is just something like, after canceling out, you will end up with it, with V of alpha minus V of beta equals V of gamma minus V of delta. This is just conveyed by these two indifferences. So in such a case, this means that you can completely focus on the utility function by just taking into account these ordinal preferences. What does this mean, this implication? This implication means that if you have used this stimuli to determine this difference in terms of utilities, then you should be consistent in your evaluation, and you should obtain exactly the same differences in terms of utilities. This means that if you have here V of alpha minus U of alpha minus U of beta equals U of gamma minus U of delta, then you should also have here U of alpha minus U of beta equal U of gamma minus U of delta. Despite the fact that you have changed the common ingredients here and the common ingredients here. You can see that this cancels out under discounted executility, and this implication means that you should maintain consistency. So your utility differences are not dependent from the ingredients that are used to elicit them. Well, it turns out that this condition, along with the previous conditions, is sufficient and necessary to have discounted executility. So, hence this theorem, discounted executility holds if and only if the preference relation satisfies this guy, this key axiom, and the standard axioms that I have presented before. So, this way, you have a very simple axiomatic setup for discounted executility. By the way, this axiomatic setup mimics a little bit the axiomatic setup of subjective executility a la Anscope-Aumann. It's a two-stage. Okay? Well, you could tell me, well, but this is not the objective, because discounted executility is not descriptively that good. We should integrate in it the fact that we have two utility functions, and in addition, you should account for the discrepancies from executility. Well, this condition can make it. You have just to split this condition into two different conditions, one condition that focuses on risk and one condition that focuses on time, that are exactly similar, except that they are a little bit restricted. For example, let me give you an illustration. If you, for example, here, if you restrict this proposition to only constant stream with an alpha level, a constant stream with a beta level, a constant stream with a gamma level, and so on, then you will end up with a consistency condition for risk. And then you can also elaborate another condition for time, and then splitting this into two parts, end up with the generalized discounted executility, namely discounted executility plus two utility functions. The interesting thing that also comes with this axiom is that if you impose a rank ordering of consequences, namely if you evaluate this guy by taking into account the rank ordering of consequences, and you have this axiom that is split in two, then you end up with a rank-dependent discounted utility, as illustrated here. Let me illustrate a little bit in preparation of the presentation of the experiment. So here, discounted executility in risky and riskless situation. If you take here, for example, this guy, namely just with streams of outcomes, giving you x at t and here x at t at the end, and here y t and y capital T, then the evaluation of this through discounted executility is just this guy. Namely, this is probability times discounted utility and discounted utility of this guy. Now, if you go one step further, if you replace these streams of outcomes by their present values, then you get here scalars. And if you get scalars, then this gives you a value of your initial object of choice. Namely, this is its value using the v function. And here, to be a little bit provocative, I'm using also the u function because this model could not distinguish between v and u. So this is exactly similar. Now, if you go one step ahead and then take into account the generalized discounted explic utility and take into account two utility functions, then this guy, in which streams of outcomes we replace by their respective present values, gives you this value, which consists in using here p times phi of v of this number. So here you get this decomposition, or this composition of phi and v represent the von Neumann-Morgenstern utility function. Okay, so well, this is just to show that you can use generalized discounted explic utility. Don't be impressed by phi because phi disappear. So you can compare deterministic streams of outcomes by using this guy. Obviously, the phi here, which is a strictly increasing function, doesn't matter when comparing with the stream because it will cancel out. Okay, when it comes now to the third model, namely the rank-dependent discounted utility, here we replace probabilities. We take into account the same formula as in the previous slide, except that we replace probabilities by their transformed probabilities. Namely here, WP instead of P, and 1 minus WP instead of 1 minus P. So that's it. Okay. Let me now explain how we illustrate, through experimentally speaking, how we illustrate that using discounted explic utility is not that efficient. It's not that reliable. Here, I take into account a method that we designed in which one can easily and immediately obtain discounting just through one single indifference. If you, for example, if you take this lottery that gives you x with p, and you equate it, or you determine the t, the timing that makes you indifferent between these two guys, then under discounted utility, and without the interference of utility, you get dt is equal to p, immediately. And this mimics Anscope and Aumann. By the way, in Anscope and Aumann, if you want to determine, for example, the probability of an event, then you have just to build something like that, replacing t by that event. Okay, so this simple equality shows us that, yes, under discounted explic utility, we don't even need to use something a la Springer, a la Andreon and Springer. You have just to use this indifference, and you are done. You can immediately get this. But, well, this is not that satisfactory if you take into account now the discrepancy that may exist between u and v. Assume now that you have different utility functions, one utility function for time and one utility function for risk. In such a case, you can see that easily that under generalized discounted explic utility, d of t is equal to phi minus 1 of p. So here you have the interference. Here, instead of having dt equal p, you have the interference of the difference between these two utility functions. So here, one can see the impact of taking into account the difference of the utility functions. Then here, always using the same indifference and assuming a rank-dependent discounted utility, namely taking into account the fact that utilities are different and possibly you have probability weighting, then in such a case, you have dt is equal to phi minus 1 WP. So you have here two layers of interference, namely the first layer is due to the difference between utility functions and the second layer is due to the probability weighting. So here you can see the bias. The bias can come from violations of explic utility and can come also from violations of the uniqueness of the utility under discounted explic utility. Okay, here is the experiment. So I think I have time. Yes. Well, subjects admitted. This experiment was, we ran that experiment in March and April 2016 in Germany. So we take German subjects. I hope that this has no impact on the results. Experiment we conducted in individual interviews lasting 1 hour and assure data quality. Instructions were shown in recorded video and in addition to written reference. And finally, subject answered comprehension question before starting the actual experiments and did practice questions. Here we have three elicitation tasks, three main elicitation tasks. Namely, we determine a risk equivalent, like in the previous indifference I have shown a few slides ago. We use simple certainty equivalence, just under risk, and we use also time equivalence, namely in differences of this kind. ZT, for example, Y prime T is equivalent to. So here you fix three outcomes and you determine the fourth. So this way you can get three structural equations that allow you to elicit your model. Here is an example of choice display, namely, for example, when it comes to eliciting a risk equivalence here. For example, the subjects have to choose between, for example, in this case, between the lottery that gives these two outcomes in 3 months. The upper outcome is given with 40%. And here, he has, or she has, the sure outcome given in 6 months. So this is a typical display that was used. Well, let me go swiftly to the results. And here we can see the discount factors assuming expected utility. Let me explain a little bit. The curve here, the brown curve here, is the elicitation of discounting without a risk. There is no risk involved here. And the yellow one is elicits discounting or discount factors while risk is here. So as you can see here, there is a difference between these two series of discount factors, and this can be confirmed here. As you can see, these are the discount factors that were elicited, risky and the riskless, and Wilcoxon, for example, Wilcoxon test show that they are significantly different. Although they are correlated, they are highly correlated, they are significantly different. What will happen now when we will introduce the possibility to have two utility functions instead of one single utility function as assumed by discounted expected utility? Okay, here we introduce the phi. And as we can see from our estimations, we can see this is, these are the kernels of the corresponding empirical distributions of CES utility functions. Namely, here for risk we use the rho, and we use the theta for intertemporal utility, and we can see that the distributions over all subjects are different, and this equality is rejected in our data by a specific test. So here we have a difference. Namely, the phi is not linear, and this confirms the Andreanu and Springer result. Well, but this is not the objective. This is not the ultimate objective. The objective here is just to illustrate the impact of this on the results. Let me remind you that initially, and without, under discounted expected utility, and the traditional discounted expected utility, the discounting curve in yellow here correspond to risky, and in brown here, the brown line corresponds to riskless. But suddenly, and because we are taking into account now the possibility of having two utility functions, then we have reduced the discrepancy between these two guys. And this is also confirmed when it comes to test regarding discount factors. As you can see here, the null hypothesis is not rejected for delta 1, delta 3, namely delta 1 months and delta 3, and for delta 11, except it is rejected for this in these 3 cases. So it improves a little bit the result. So taking into account two utility functions instead of one have improved the results. Let me now introduce, in addition to the possibility to take into account two utility functions, we take into account the possibility of nonlinear probability weighting. And here are the curves. As you can see, suddenly we have now the red curve and the brown curve that are almost the same as compared to the curve corresponding to the risky case. And as you can see here, when it comes to tests, Wilcoxon pair test shows that we have no significant discrepancy between discounting factors when it comes to risky or riskless situations. So this shows that taking into account two utility functions is not enough. One have to take into account also discrepancies from expected utility. Otherwise, you will have some problems with the reliability of your estimates. Okay, so few concluding remarks. And well, here we have a new method to elicit time discounting, by the way, because let me remind you one thing, and I think it's important enough. There were fiddling in the existing literature to try to elicit discounting while utility is there. Many economists and many psychologists, and up to the 90s in the last century, have assumed, when eliciting discounting, have assumed that utility was linear. They assumed the linearity of utility. Then there was this paper by Glenn Harrison and colleagues in 2008 in Econometrica, in which what they did is that they have elicited the utility and the risk, and they put it within discounted utility. Well, they have posed the problem. They have solved the problem, but they have posed other problems. Then they have posed the problem of the very nature of the utility function when it comes to discounting under discounted expected utility. And I think that this with this setup, we have solved the problem. Let me also insist on one thing. One difference between the theoretical setup I'm presenting here and the theoretical setup à la Krebs and Porteus is that under Krebs and Porteus, they take into account delayed resolution of uncertainty, while here we don't take into account delayed resolution of uncertainty. Namely, here, uncertainty is resolved from the early beginning. It is not delayed at all. The second conclusion, here we have, well, generalized discount expected utility model allowing for a bias-free measurement of discounting. Let me insist again that in this model, we don't impose that discounting is exponential or is constant. And finally, generalized discounting expected utility could better, rank-dependent discounted discounted utility are better described. There is a typo here. Describe behavior under risk and over time. So I think that the main message of the paper is just to say that you love discounted expected utility. It is a very powerful model in terms, normatively speaking. But when it comes to its descriptiveness, it is a weak model, and it could not be used in a reliable fashion when it comes to elicitation of intertemporal preferences when risk is at play. Thank you. Yep.
It's a marginal question, sorry. Since we are near engineering school, I was wondering, what about the Carnot cycle? Okay, we are late, so I can ask a kind of crazy question. But if you take an individual and you give for certain some amount of money at time t equal to 0,
yeah.
Then you say, okay, I will give you this amount with some probability, and then I ask your compensate.
Yes.
Then I say I give it with this probability, but I give you at time t1. I ask you the compensation. Then I come back. I remain at time t1. I give you the same with certainty, and then I come back at 0. And my question is that is the sum of so you do like a
circular stuff.
Circle, yeah. You go back,
yeah.
And each time I ask you the compensation. Is it the case with your model that the sum of compensation is 0?
I'm not sure. I'm not sure that the sum of the compensation will be 0. I'm not sure. I didn't check it, but I'm not sure at all.
Certainly, I could not know.
Yep.
It's a general question. Yeah. Don't you think when you are talking about risk, maybe you use money as outcome? Yeah. So basically we have indirect utility of waste.
Yeah.
And when we use in economic theory utility about consumption, it's the expense of consumption, so it's money. Yeah. But We have more the idea that it's the utility of consuming something as a simplification, of the case in which we have many goods. And in this case, the risk aversion of the indirect utility of waste will not be the same that risk aversion.
Well, if I understand very well, I think that your question is related also to the nature, to the very nature of the attribute used, namely money versus consumption. And I think that this is a problem that has hindered the experimental work when it comes to decision over time. Because of fungibility of money makes things too artificial as compared to consumption. And this is problematic. This is really problematic. We have accumulated tons of findings using money, but not using consumption. We have repeated, by the way, with my co-authors, we have repeated this experiment, the same experiment in India, using it for rice and tea instead of money. And we get slightly different results. But still, in terms of biases, it's the same result. One have to take into account probability weighting and to take into account the fact that there exist two utility functions. But I think that you're right. I think that a lot of, it is almost a waste of time to use money systematically because these models were elaborated for consumption, for goods.
Some of the other stuff by Sprenger, they use the labor supply.
Absolutely, yeah, subsequently in a subsequent paper. Yes.
They do get different results with labor supply and consumption, I guess.
Yeah, absolutely, yes. We have also elaborated a similar experiment and René and Sprenger using losses of time and gains of time. And I think it makes a difference. There is a big difference between money and other attributes. So thank you for the question. Thank you.